Okay, so if we're talking about Pythagorean theorem, I want to start looking at this shape right here. What can you tell me about this side right here? Good. It is the longest side. Great job. That's your C. What else can you tell me? What is it called? What can we name it? Starts with an H. HY? Sounds like a word. Sounds like a word you use in science. Hypotenuse. Absolutely. Okay. So somebody tell me, what can I call this line right here?
A.
Okay, I can call it A or B. It doesn't matter. I can call this one A or B, but those two you can switch. Anybody know what we call them? This one's your hypotenuse. This one starts with an L. Leg. And leg. Okay, those are our legs of our triangle. We know that the hypotenuse has to be the longest, right? But why is it that A squared plus B squared equals C squared? I want you to think of it this way. It is not A squared, it is A squared plus B squared equals C squared. Notice that this triangle is inside of these blocks, right? So this side right here is 3 units long, correct?
Yep. Yes.
All they did is created a box that's a 3 by 3. Because this is 3, I just created a square. The one on the bottom has how long? 4. So I created a square that has 4 blocks. If I take these two squares, the smaller two, and add them together, I get the same number of blocks here. That is what creates a 90-degree triangle. Okay, here's a visual. Are you ready? So if these squares, I put right here, and these squares right here are right there, I have the same number of squares, so my picture in the middle is going to make a right triangle. If I have not enough squares, I'm going to have an acute triangle. And if I have too many squares, I'm going to have an obtuse triangle. But it is when I have the same number that this picture right here in the middle makes a right triangle. Does that make sense? So it's not just some formula. I mean, it is as a shortcut, right? But what they're talking about is the area of these two squares being equal here. That's what makes that picture in the middle a right triangle. Are we okay? So, I want you to look at this one. Okay? One of the things that people get messed up on is you're seeing A, B, and C. Do you see A, B, and C? One of the things that you need to know is that B is a capital letter, correct? It's talking about that point. It's actually talking about that angle. We'll get to that next unit. The side that's across from it is your lowercase b. Okay? Right here is a capital C. The one across from it is my lowercase c. And this is my capital A, so the one across from it is going to be my lowercase a. Now, these two can really switch. Okay? On your SAT or PSAT, they could give you a triangle where it was R, S, and T. They're talking about these points, R, S, and T. So this would be R, this one would be S, and this one right here would be a T. Right. Now, if I'm trying to do Pythagorean here, they don't have A, B, and C. Is that okay? Yes. It's still the one that's across from your 90 degrees is going to be your C. They just use different letters. Are we okay? Questions about that? Because that's where some people get confused. Well, they use different letters. They put an X in there. Well, don't worry about the X. They're just saying that I want to know what that piece is. Okay? I want you to try this example right here. I want you to try. You try it. On your paper. We have a formula here. Right? I'm looking for you to try and mess up a little bit. It's okay. The first thing I want you to do is to find C. Which one's C? Circle it on the picture. Which one is C? I want you to circle it. And then look at your formula. Alright. So the first thing that people mess up, okay, is you have to find C first. C is the one that's across from the 90. In other words, this side right here touches the 90 degrees, and this side right here touches the 90 degrees, right? You'll never ever use those two as your C, ever. They touch the 90 degrees, I don't want to use them. It's the other side I want to use for my C. So if I plug it into my formula, a squared plus b squared equals c squared. My c is just c squared. The other two were my a and my b. So I'm going to take 20 squared plus 30 squared. Does it matter which one goes where? If you put 30 squared plus 20 squared, I'm okay with that. So what is 20 squared? In your calculator, it is not 20 plus 20, it's not 40. Okay, in your calculator, type 20 squared. The squared key, you see the blue one? The green one, there's a math key, there's another key, and it's the one right above the log key.
I just did 20,000.
That's fine? That's fine? And you got 400? What's 30 squared? 900? What's 900 plus 400? 1,300. Okay, now this is the next spot where people mess up. Because they want to divide by 2. This does not mean divide by 2. Okay, sometimes if you have a negative 1, the opposite is a positive 1, right? Those are called opposites.
Yeah.
Okay, the opposite of a squared is a square root. Those two things cancel each other out to leave me just a C. If I do a square root here, that means I have to do a square root here. So in your calculator, you're going to hit the second key, the blue key. And then you're going to hit the same key you just hit to square it, the one above the log. And then you're going to type 1300, enter.
Say it again.
Okay, hit second and the key right above log. 1300, enter, and you get what?
36.
36 point what?
06.
06.
0.05. And that's the equation. That's it.
Now, you need to double check because it's easy to make a mistake. Should this side right here be my longest? Should it be my biggest side?
Yes.
Yes, because my hypotenuse is my longest. This one's bigger than the other two, so I'm good. Okay, if I don't tell you how many decimals, you always put 2. Some of you are like, but I didn't get that. I had 36.055 something, right? Always put 2 places. So if I go 2 places, I look at the third one, it's a 5. That tells me to bump that up to a 6.
So look at the 4.
Okay, then you would just leave it as it was. Thank you, sir.
So when it's squared, you always have to find the square.
Yes.
Okay.
Okay, I want you to try the bottom one. Careful, careful. Look at it again. Compare that one to the one above it that we just did. How's it same? How's it the different? Look at the next one down below it. Tell me what's same and what's different. Be careful, I'm tricking you.
You mean the one that says find A?
You just write this.
find A. Well, how's that different from over here? I want you to think of it this way.
Subtract.
In the first problem, I have to find C. In this problem, they gave me C. Are you with me? That's really the difference. Here I'm finding C. Here they gave me C. So the first thing I told you on that first problem was to go up there and to find C and to plug it into your formula. And then you have to do A and B. Those are the other two. So it's going to be A squared plus 12 squared. Right? Some of you automatically took those two numbers and added them together. You said 12 squared plus 13 squared. Somebody did, I promise. Okay? But you have to find C first. Okay? So put C in the formula first and then put your other two numbers. So this is going to be A squared. What's 12 squared? 144. And what's 13 squared? Okay? Now, just like the problems we've been working, I need to get the A squared by itself. What would I do? Subtract the 144, right? So now I have A squared is equal to what? 25. Okay, I'm not dividing, but remember the opposite of a squared is a square root. So that means that A is equal to 5. Could this side be 5? Why? Because it's smaller than 13. And 13, it has to be the biggest number. Okay? Okay? If I look at this one and I see that they have the same denominators, then I can put the other denominator over here. But I know another trick. I see a 4, I see a 5. I know this one is automatically a 3. Because in Pythagorean theorem, the smallest right triangle that I can have is a 3, 4, 5. That's called a Pythagorean triple. So if I see the numbers 4 and 5, the other side has to be a 3, if it's a right triangle. But Ms. Ramsey, what about 1, 2, and 3? Well, let's see. 1 squared plus 2 squared has to be equal to 3 squared. The question is it? Well, what's 1 squared? 1. What's 2 squared? And what's 3 squared? What's 1 plus 4?
5.
Is that equal to 9?
Yes.
No. So that means that's not a right triangle. It can't be. But Ms. Ramsey, how did you know that the 3 is the C? What do you know about C? It has to be the longest. It has to be the biggest. So these smallest numbers I can have are a 3, 4, 5. Okay, Ms. Ramsey, that still doesn't help me. The one across from here is my C, right? Okay, so that means I'm going to have x squared plus 4 over 9. Look here, these have to be squared. And that's going to be equal to 5 over 9 squared. Okay, hold on. I'm going to make it simple for you. Okay, I promise I'm making it simple for you. Okay, what is 4 squared? 16. What's 9 squared? 81. How many of you didn't square the bottom number? Okay, that's going to be equal to, what's 5 squared?
25.
25. What's 9 squared? So here, wouldn't I have to subtract 16 over 81? Subtract 16 over 81. I have the same denominators. So what's 25 minus 16? 9, right? That's going to be equal to 9 over 81. Now, some of you automatically go to try and reduce it. Don't. Because, Yeah. So right here, 4 squared is 16, 9 squared is 81. 5 squared is 25, 9 squared is 81. So now I have to subtract them. So 25 minus 16 gives me 9. Are we good?
Yup.
Okay. Now, I have this squared. That means I have to take the square root, right? What is the square root of 9? What's the square root of 9? 3. What's the square root of 81? 9. Okay, I know that x squared, if I just reduced it, you had 1/9, right? But I'd still have to go back and take the square root. Where if I did it here before I reduced, then I have 3 over 9. Isn't that what I